Hello, good morning. It's April 26th today, and I'm going to start off by warning you that I'm having a lot of trouble hearing today. I think I mentioned in the last couple of videos that I'm having some trouble with wax in my ears. I am treating that now, and the result is, as I stand here, both of my ears are totally blocked. So, stick your fingers in your ears and listen to your voice. That's what I'm hearing. So if I start whispering, it's because my blocked ears are doing it. And how can you fix a radio without ears to hear it? Well, we're not going to be listening to this radio for a bit. We're going to look at the schematic and study up on that. But I already have some interesting observations about this radio. First of all, these push buttons. No, these aren't push buttons. So push buttons really refers to buttons that you push in. It would be a push button. Well, these are push buttons of a sort, but I'll explain what I'm getting at in a moment. If these were push-in buttons, then a small radio, when you go to push them in, the radio moves. So you'd have to hold the radio. Hold the radio and push the button in. A big radio, that doesn't happen, but on a small radio. So push buttons on a small radio is a bit of a problem. It's an annoyance. To defeat that annoyance, rather than have the button travel that way, you have it travel down, and you push it downwards like these, and then the radio isn't. I just put my finger through the speaker. I think I just put a hole in it. That's okay. Other holes anyway. So this is a feature that you'd want to sell. So you don't want to call these push buttons. You want to call them something else to highlight the fact that this radio is made with push buttons that you don't push. Well, you do push. You push them down, but you don't push in. Small thing, but it's something. Now, if you notice, here's the output transformer. It goes to the speaker. Hey, what's this? So I didn't notice this yesterday when I started working on it. So this one is a choke coil in the power supply. It's very unusual to have a choke coil. In some of these older radios, this function, if you like, is done by the speaker. But this radio has a let's just make sure. It has a permanent magnet. You can see it holding onto my screwdriver. So there is no field coil. Field coil cannot be used as the filter component in the power supply. So instead, here it is here, in the form of a choke coil. So that should make the need for the filter capacitors go way down. My experience is a radio with a choke coil doesn't need much capacitance in the capacitor. You usually have a capacitor, choke coil, a capacitor in a what's called a pi filter configuration, and that's true in this radio. So, this was originally a 40 and a 20, and then this was put in. This is a 40 and a 40, and now I put in mine. They're a 47 and a 47. They get bigger and bigger all the time. But I don't think that's going to cause any kind of problem with it. At the most, it's just super filtered. Now, am I wrong? Wasn't there a slight hum in this radio? Even though I've changed the capacitors and it has this filter here. Or coil, inductor, choke. I think it did hum a little bit. So we should investigate that. I'm pretty sure I know what's causing it. It's not this, but probably we should pay attention to that. What I really want to do today, though, is look over the schematic, the alignment instructions, perform the first alignment to see if the radio's out of alignment. Maybe it's not. Whoever worked on it last quite obviously knew what they were doing. But they may not have had a shop with the equipment necessary to align a radio like this. They may have done it by ear. You can get, if you know what you're doing, you can get an okay result out of that. The dial might be way off, but so the dial pointer is critical on here too. If you look, a part of the alignment process. There's no key in here, inside here. So this can go on any way at all. So the position of this pointer is important. There are instructions on how to position it. The instructions. I think the instructions are based on the angle of the capacitor, if I remember right. So you would tune the radio. Incidentally, this style of button, I should carry on about these, that mechanically move the tuning capacitor like this, so the radio's tuned in its normal way. I think this is a much better system than the other type where the buttons are connected to actual coils or tuning components, and you switch off, when you use them, you switch off the variable capacitor and you switch on some fixed coils that you slug tuned to a certain station. That's not a very good approach. What are the chances that you're going to get it smack dab on? Not all that great. They're going to stay that way. Not all that great. But you can't tune it or fine tune it without going in the back of the radio, getting out a screwdriver, and removing some slugs. This is not like that. This one, you're actually tuning the radio VFO, like that. The beauty of it is, if the button is not exactly right, which it probably won't be, this is really getting you right to the station, and then you fine tune. And that's a far better arrangement than the other style. I suspect the push buttons on all those other radios were never used, or seldom used, because you can't push the button and then fine tune. It doesn't work like that at all. Okay, enough on the push buttons. We should study up on the schematic. We want to find out what is going on with this strange, what looks to me like a weird arrangement. This card here is weird. That's a weird thing. And we need to know a little bit about alignment, where to feed in an alignment test signal, and whatever else we might find in the schematic. Maybe we'll find some interesting stuff. Okay, I'll drink some coffee and then we'll look at the schematic. Okay, here we go. Now I got this from Radio Museum. I'm a member of Radio Museum. And this isn't the best copy. Now I have one of these exact, well, it's not exactly the same, but I have this schematic stuck underneath the chassis here, and I'm just doing a quick comparison. And okay, so this one's been marked up a little bit. The one on the screen you're looking at's been marked up by somebody. Quite a few notes on it that aren't on the version that's glued to the chassis base. Things like this note, 150 ohms here, or this note on first production only. That's interesting. Now, who would know that? Well, it'd have to be the manufacturer. So how it is this schematic contains this information, but the one I have doesn't. There's a little dotted line there on a component. First production. Yeah, there's many versions of this radio. And there's the same serial number has a number of chassis associated with it. My belief is I've got the right chassis here. 132.802.1 is what's written on this radio. Nothing more though. There's no 1A or 1B, so it's a dash 1 version. See, on first production only. So would that be the number 1 here? And like the 1A and the 1B would not have it? I don't know. It's interesting. It's part of the antenna. So we're going to get caught up on that. So I'm just doing sort of a general overview right now, just noting that these little notes have been put in, 0.05 microfarads, or megafarads is always used right now. Okay, so let's just look generally around. Here's some notes here. Models 3351, that's what I have. I have the 3351. And chassis, yeah, this one here. So quite a few radios covered by this. There could be a lot of information on here that does not apply to the particular version I have, so I have to be a little bit careful. Like, here's another thing. First production, second, and third. Oh, these are dates. First production. April, that's interesting. So January, February, March, May. So May, yeah, very end of May. Middle of July they changed it, and then late October they changed it. So they run for a few months. Then they probably start hearing back. about their design from people, probably. Or, even while this thing's in production, they're working on the next model right away. So maybe that's all this is, just natural progression. But it makes things confusing. Floating ground, single capacitor to the chassis. Another connection to the chassis here. Bottom of the antenna. Notice the antenna has a separate part here, and then this part is connected to the radio itself. And it's just via transformation. And quite clearly, this is many, many, many turns, and this does not. The secondary has only a couple. What's it say here? Let's look at this. Zoom in. When external antenna is used, remove this wire, that's this one, from the antenna. Oh, so that's what the fanshawe clip is on the back. So you would unhook this wire and then hook up the antenna. Then the antenna would feed down through here to ground, to the chassis. What's this resistor doing here? 10,000 ohm resistor. Not exactly sure why they put a resistor across here. It's pretty large. I would think all it would do is kind of ruin this coil. But without an external antenna, what you've got here is you have, I see what's going on, I think. You have this wire shorting out this resistor. Wait a minute, you have this wire shorting out the whole coil. What is happening here? Maybe I read this wrong. When external antenna is used, remove this wire from antenna clip, insert antenna wire. Now it's got to be that fanshawe connection they're talking about. Okay, so without the antenna, the wire's in the clip. This whole thing is just shorted away into nothingness. This becomes the antenna? Maybe I'm not getting this right. Kind of looks that way, doesn't it? It looks like this is the pickup coil, and then if you use an external antenna, you transform the antenna power into this pickup coil with this coil, which is hobbled otherwise by a wire going around it, and remains hobbled by this resistor, which is here for reasons I don't exactly know why they would do that. Lightning protection of some sort. Okay, so that raises some interesting questions. And this capacitor, first production only, this probably exists in mine. I'm not sure. And we move on. This is very hard to look at schematic. It's really a real mess in here. Gives voltages, 102 volts, 102 volts. What's on the plate of the output tube? 102 also. 109. Usually the power, which one's the plate in here? Oh my gosh. You're not going to be able to tell by looking at it. The plate current should be passing through this transformer and be coming from here where they have 109 volts written. So that would be the plate. Sort of. I can see it in there. So 109 volts on the plate. That's a little low for a radio like this. A single, like a non-transformer radio. If we look down at the power supply, what do we see here? Dial light right across the incoming power on the other side of this resistor. 52 ohm resistor. Capacitor right here, right across the power line. This, I think, is important to us. I think I heard the radio humming a bit. I think it may be because of this capacitor. But what I'm intending on doing is do the alignment, tune it all up, and then go back and fiddle with these few capacitors that are left in it, a few paper original capacitors. So we got this resistor here, and that's in the heater line. So this is a dropper, because these don't add. Let's add them up. Let's add them up. Well, we can add 12, 12, 12, and 35. I'm sure this is a 35 Z5. Yeah, there it is, 35 Z5. So we add 35 and 35, that's 70, 80, 90, 108. So 108 volts dropping on the tubes. They want to get rid of the other about 10 volts on this. So you get 10 volts, E squared over R, 10 squared, 100, about 2 watts here. R2, 2 watts. Is there a parts list? Not here. Oh, here we are. But they don't give a wattage. But if we could spot R2, we could probably judge from its size. R2, there it is. You see, it is a little bit big. I should be able to look right in the radio and see that. No, we'll do that later. But it's probably a high wattage resistor here. Are we looking underneath? Must be looking underneath. What can we get out of this? I don't think there's too much to figure out from here. Just which is T2, the second IF, and which is the first. Usually obvious though, because you can almost see how the signal's flowing through the radio. Skip around there to here, and back here. Am I speaking loudly? Am I whispering? Okay, carrying on here. So I'm just looking for special or unusual things that might be found in here. Added on second production. And giving a current 3.5 milliamps, I think is what they're saying. So this is the tube we want to feed into the grid. No, it would be this tube. We want to feed into the grid the well, we can assume, I think, that these two transformers are well adjusted. They're just maybe off a little bit. So in that case, we don't really need to do them one at a time, feed the signal in here. They're close. So we can feed the signal into the grid here, and the easiest way to do that is to jam it into the antenna somehow and just let it come through. Or even radiate it into this antenna and have it come through. That's even better. Radios really aren't designed to receive the IF frequency through the antenna, but I'm sure enough will get through. And then we can do the alignment or alignment check. That'll work out fine. Now where can we pick up the AVC voltage? So I usually like to do this with monitoring AVC. So it would be, it's hard to see what's going on inside the tube, but we can guess. Can you see it says something, looks like OF. This looks like OF also. These are probably the two diodes right here. It has to be a diode because it's connected back to the output of the IF. So this is developing the AVC voltage. Here's the volume control right here. The AVC DC voltage is allowed right across the volume control down to ground. Whoops. They don't capacitor block it. They block it here from affecting the grid potential. As usual, I have a huge resistor here, small capacitor here, the usual arrangement. There's no negative feedback or anything like that to really mess me up. I did a radio a couple weeks ago with an extensive negative feedback manipulation switch, sometimes referred to as the tone switch. It really just blew my head off. This one's very simple. It does have a tone control. No, it has no tone control on it. So just volume control right here. So you're going to get what you're going to get. This small speaker anyway, you know, what are you going to do? And it's AM radio, so there's not a lot of trouble to begin with. So we could tap off. We could put the AVC meter here, basically top of the volume control. Oh, I missed this capacitor. So this one is the RF drain. It's providing an RF ground right here. And then this one, this large resistor here, standing between the detector circuit and the volume, audio and all that, and the AVC line, which is here. What's it doing going back this way? Wait a minute, is this an AVC line? Yeah, because it goes up, you know, through here to the grid. Yep, to the grid count. That's the AVC line. Where I lost track of it now, I have to find it again. This one. What's it doing going back here? So typically you don't apply an AVC voltage. Oh, what's going on here? So this is the other diode. It's also going to generate a DC. There must be a capacitor draining out any RF. This is on the other side of the 2 meg. So the 2 meg is to help the audio stay up here, just by filtering and whatnot. There should be another big capacitor. Here he is, 0.05 right here. 0.05, we come along. Here's another capacitor on first production only. And then they got rid of it. That's interesting. Usually you're adding parts. First production only. They got rid of it. I think they may have determined it's not needed. It's just not needed. It's probably technically a good idea to do this. This is probably a fairly high value resistor here. Notice the value is not written. Oh, sure, right there, 500,000. So a fairly high value resistor. The idea is to isolate away the grids, which are sharing this AVC line. So the grids don't talk to each other. That's kind of how I would see it. Interesting. So as they're going along, they're learning to make this radio with less and less parts in it. And save 7 cents on the resistor. 7 cents times, 10,000 radios. Yeah, it's real money. Added. Here's something added on second production. So they're pointing at this capacitor and they're pointing at this resistor. So they introduced cathode resistor here to adjust the bias on this tube. They weren't happy with it on the first production. And then once you put a resistor in here, you start losing some signal across it, wasting some signal across it. So you can bypass it with a capacitor, force all the signal into here. That's kind of how I see it. Same thing here, but it doesn't say added. This is a plate. No, this is the plate. No, it isn't. No, it is. It says GS grid signal. What's that say? 50 volts? Does that say 50 volts? What's got 50 volts? Now this is grid screen. GS grid screen. Screen grid voltage. Oh, down here. Yeah, there we are. Whoops. You see this line is connected to the second side. The filter, better filtered. Now the less better. Oh, there's a, what? What? Okay, I'm just losing my mind here for a minute. This is the B minus. This is the B plus. Oh yeah, I don't get it. So they have this filter in the negative side of things. I'm not sure what's going on there, so I'm not going to dwell on it. But this it's just probably the way it's drawn. It's not sinking into my head properly. But for now, that's okay. Doesn't really matter. I don't have to understand everything about a radio to fix it. I just need to understand the parts that are in trouble. So that's the thing to focus on. So what's in trouble? So what's in trouble is the antenna is weirdly connected on this radio with a weird intermediate plate. But it does have the Fanshawe connection sitting on it right here that's talked about in this. Well, I think I'm just going to leave that as an open question right now, and we're going to focus on the IF and making sure it's correct. Now, somewhere I saw, so I didn't read all these notes here. Let's look through these notes. Each button is set up by loosening the screw under the push button key, tuning in the station, depressing the button, then tightening the screw. Okay. Alignment notes: with the variable condenser closed, the pointer should point vertically upward. So there's the hint on how the pointer goes on. When properly set with the variable condenser closed, the pointer will point just to the right of the 54 calibration mark. I have to put it back in the cabinet to do that, but the first one we don't. It doesn't really matter until it's in the cabinet. You can't read the dial, so it doesn't really matter what the pointer's pointing at. How to set the position of the dial pointer with variable fully closed. You just see note below. How about the note above? Output meter connection across loudspeaker voice coil. I'm not going to do this because this is a noisy way to do it. Output meter reading to indicate 50 milliwatts. I guess they're giving you some notion as to what kind of voltage you're going to see here. Point less than a volt. And instructions on doing the actual alignment. Generator connection. So 12, 8, 8 grid. So they're saying put it right on the grid here. That's just pretty much putting it on the antenna, but I'll follow what they're saying because it's going to go through both transformers, and that's easy. This grid is a cap, very easy to connect to, so that's a good way to do that. The low connection goes to the frame of the capacitor. The frame of the capacitor is connected to the B-, not to the chassis, so you're getting a B- connection there. And you're adjusting the trimmers that are found in T1, T2. Notice they go T2 and T1. So do this one first, then this one. It won't really matter in a radio that's close. It doesn't really matter, but it is better to do this one. If your radio's way off, if somebody's twiddled these and it's 5 miles out, you need to kind of feed the input here, get this guy going properly, and then you can move the input back to here and get this guy going. If it's that far out, and I have had the odd radio that is that far out, power output type, beam power tube, undistorted, 1 watt, maximum 2.6 watts. You know, like that's a lot of power into a little tiny speaker like that. That's a lot. Tubes and functions, oscillator, translator. Look at the word they've picked here. Translator. That's interesting. So what these radios are really doing, it's almost like solving a code. Remember when you were a kid, you did this code where you took the alphabet and you shifted it 3 letters over. So A became C and B became D and so forth. And then you'd write your code, shifted code, and then you give it to your buddy and say, the secret number is 3. And then you shift it back and you could undo the code. Well, to some degree, that's what's going on in this radio. It's shifting the incoming frequencies down to the frequencies we're interested in. It's shifting them all, but the ones we're interested in are being shifted down around 455 in that range. Sometimes we think of it as a mixer. You think of the incoming signal and it's getting mixed with the local oscillator. It's producing a single frequency at the IF and it's carrying on. But really, everything on the antenna is being shifted. It's just one of them is shifted right onto 455 and then it's going to come through the radio. They like the word translate. Shifted is actually better, isn't it? Shifter, frequency shifter, I would say. Okay, now I'm dwelling because it's good to dwell on these things because that's when the stuff you didn't notice yet, you notice. Tube sockets are viewed from underside of chassis. Voltage readings shown at socket prongs are to floating ground and are taken with no signal, AC line voltage 117, where no readings given, the voltage is 0 or just too low to read. They don't hint at what kind of meter to use, but that's okay. It could be that the reason you're reading these fairly low voltages here, they're using a crappy meter to do it. And they were actually a little bit higher if you read them with a better meter. Could be. 35 watts. Okay, I don't think there's much more we can extract out of here right now. The key thing is, as is commonly the case, top of the volume control, good place to go to get an AVC voltage. Be on the detector side of this great big resistor. And feeding the signal in. If necessary, we can do the grid here, but we can probably just do the grid here and get the whole thing done. Perfect. Okay, I think I got everything ready here. I've got my signal generator running. Right now it's at 435 kilocycles, so it's below the IF frequency. I've got this meter connected up to the volume control where I can pick up the AVC voltage. That's what this yellow clip lead is coming out of the radio. So I'm going to turn on the radio, get it operating. I'm going to pass the IF frequency through it, back and forth, and we're going to listen for a peak, or maybe 2 peaks, or whatever we hear. And we'll figure out what frequency the IF is centered on, and then we'll see if we need to do anything about it. Okay, so the next step is turn on the radio here. Just plug it in, get control of the volume. Okay, it's switched on, applying the power. Here we go. By the way, so this guy and this guy, they have 3-prong plugs and they are grounded. So what I've done is I've taken the ground lead from each of these on the test lead, and I've made sure I've connected to the same place in the radio. In this case, the B- as it's found on the frame of the capacitor there. You don't want to put 2 grounds in different places on one of these radios. You can get some unexpected excitement out of that. Here we go. Okay, so I just a little too late now, but the dim bulbs came on very briefly and went off. It's interesting, but the old capacitor, filter capacitor in there, those lights came on and stayed on quite a bit longer. I put a bigger capacitors in here, and they seem to charge up a lot faster. I don't know what to make of that. Okay, a little volume. Good show. I can hear the radio. Yes, my left ear is unblocked at the moment, so I can actually hear now, as opposed to earlier on. So we don't really need to listen to the speaker, but I like to hear it anyway. Now we're going to tune the signal generator, and when we go past the IF frequency, it should make a tone. There we go. I did not hear a thing. Okay, well, maybe we need to hook this up. That's probably the part of the deal I'm missing. So I have a capacitor clipped here. I didn't mention it onto the grid, so we're going to hook this up. This will probably knock the radio out. No, didn't knock it out. We got more hiss. Or is that just my ears? Okay, let's go hunting this time. Too high. Still too high. Wow. Too low. So it's making a heterodyne sound, that beep sound, because there's some other signal coming in coming into the radio, some interfering signal. There is, I noticed this the other day, there's a strong interfering signal in my house at about 450, 449. And this, we're trying to use 455 for the IF here. Guess who's coming along? That tone you hear is probably that interference signal. Now, let's see if we can't figure out, watching this meter, it didn't make much difference. I would say there we get the highest AVC response, 457. My counter's a little low. That's probably actually 458, 459. Close, but not where it needs to be. Now, and is there just one peak? Sounds like it. So I'm going to put this on 455. I'm going to increase the output. Oh, you're not supposed to do that because it creates a big ADC voltage. Well, I'm going to do that. Turn this just down a little bit. To start anyway. And we don't need to listen to it. We just need to watch that meter. Okay. Starting with the second IF. Using a metal screwdriver here, so I'm watching the meter while I tap it here. Nothing happens. There's a short spark because this frame is part of the chassis and is stood off from the B minus a little bit. And no telling what's on these screws. This can get exciting, but hopefully it won't. I already saw a little blue spark. Why am I using this screwdriver? Just because, you know why? It just happened to be on the bench and in my hand. So watching the meter in the background now. Oh my gosh, this guy's stuck. Close. Very close. Okay, you can't see the difference in that meter movement from there. Tiny amount of difference. I'm going to change screwdrivers. This is actually a neon testing screwdriver, the Junior Testoscope from Manchester, England. So if you touch this to a voltage source and then touch this part here, you'll turn on the neon bulb that's in here. There's the neon bulb. Don't think I really want to try it, but I'm sure it would work. But the problem then is that there's, my finger is connected through a neon bulb to here, and I'm using it to do a radio thing. Probably not the best idea. We'll try this little screwdriver here. Okay, other screw now. On T2, watching the meter. Very close. Okay, not much happening there. We'll try this one now. Did that affect the radio? No. This hole here is all chewed up. Probably by somebody jamming too big a screwdriver. This one's kind of messed up too, from being clumsy with a screwdriver in there. That's probably what that is. Not me. I didn't do it. I am innocent of that. Okay. Eeny, meeny, miny, moe. We'll start with this one. Again, not getting much out of this. So you can think the last guy who did the work on it did this. And he did an okay job on it. Yeah. Oh, this one's a little... Oh! Ah, we got one. This one was a little bit out. We're still at the right frequency. Okay, now we'll go back through them. And these ones, they can't be making much difference here. Oop. Ground out the screw briefly. Too small a screwdriver. Very hard to turn, but these aren't going to be out. These aren't. There's no reason to do this. What I'm doing. Oh my gosh! Okay, so a little bit out, but not much at all. Now, I'm going to stop for a minute, read the instructions on the next stage. The next stage involves just adjusting the oscillator and the antenna. And if we lift the oscillator alone and just adjust the antenna right now, let's do that. Even though later the antenna adjustment may not be correct, but let's just see if it's way out or not. I'm looking for stuff to be way out. Not very likely. I'm going to need a bigger screwdriver. Give me something with some power in it. This is a big, big one. Oh. It doesn't seem to affect the radio any. Okay, here we go. No change. Well, that's, dumb, because I'm running the IF right now. That's not the right thing to do. Not the right thing to do at all. IF is done. Got to relocate this input to the antenna. Where exactly on this crazy antenna? I said before I could feed the signal in just by pressing it into the antenna. Let's do that. Let's do that, because that's going to be the least disturbing of the radio. So we're going to take this coil and just throw it right on top, like so. We're going to take this off here. We'll just charge up this coil and transform some energy. Oh, you can hear it. So of course that's the IF frequency going through. But we want to, first of all, the radio is tuned with the capacitor closed. So that puts it at the bottom of the, so I'm just going to dial this up. Oops, dial this upwards. And when I hit the mark, we should hear it. We should hear it come out of the radio. The mark being 530, 540, something like that. Okay, I'm going to watch this meter now and set this for the maximum. Okay, 547. So with the capacitor completely closed, the radio is receiving 547. Doesn't sound quite right, but that's an oscillator issue. We'll fiddle with that in a minute. Let's try this one again. So this is the antenna adjustment, if you like. Show me some goodness. No. It wants to tighten right down. You probably can't see it, but the meter's just moving a couple of widths. That's all. That's not so good. The local oscillator is out of the range of the tuning of the front end. That's not so good. So if we can move the local oscillator a little bit anyway and get it somewhere where it should be. I think this radio, what did it say? It said something. Yeah, I'm going to stop for a bit, just read up, and then we'll carry on. Okay, I think I know the secrets of the pointer. With the capacitor completely closed, that's where it is now. The pointer should be not quite straight up. It should be just a little beyond straight. And the way you judge this is you look at this guy here, and you see the 5.4. It says it should be just to the right of the 5.4 marker dot. Well, it's basically straight up. That's how I see it. So we have this there. We put this straight up. Now, the next two stages are done at selected frequencies. So one of them is 1400. So I've got to get the pointer at this kind of angle. I'm not going to put this on. I'm just going to judge it. Now, wait a minute. Now, wait. Let me just look at the instructions, because maybe the next stage isn't. Yeah, it is. It's 1400. 1400. That's where they want you to do the oscillator and the antenna. So 1400 is a certain amount of guesswork here. Is that even straight up and down there? So both this and this are slightly off straight up and down. So how am I going to get over here? I can measure some kind of angle. Just do it by eye. Do it by eye. I put this here. Sitting here. You can join me on this. Yeah, is this accurate? No. This is not going to be accurate. Let's set it right here. Okay, so how does it compare? maybe is it the same angle? Could I actually put this over here? Is it? Can you do this? What am I doing? I don't even know what I'm doing here. Get down closer. Don't drop it now. This doesn't help. Yeah, dead on. Yeah, dead on the money. Perfect. Okay, so this is tuned to 1400, so I think. Yeah, we'll just tune the, let's send over a 1400 signal and see what it does with it. So it likes it way up here. Not very sensitive. So instead of 1400, it's 1450. And you can see the difference between 14 and 1450. I mean, it's just a couple of degrees. A radio like this in this part of the world is going to be tuned to the other end of the band. The other end of the band should go just below 5.4. So it looks like it should go just below and hit 5 point. Let's go down there and find out where we are with this. 450, and it should be 440. Let's drive it down with the 440 or less. Let's drive it down with the oscillator here. Hey, what's going on? Well, what am I doing wrong here? Oh my gosh, 450. What am I doing? How about, that's 450. How about 540? How about 540? That's dumb. Dumb move. Okay, so big wide signal. 5. So we want this to be maxed out just below 540. So we go down here. I'm not following the instructions now. Okay, I can see the meter just over here doing its thing. So the radio is now set so that 540 actually should go just a little lower than 540. Let's go down there. So the very bottom now is receiving about 530, 535. So we go up to the top again and see what's happened. The radio seem a little more active here. Oh, it's that crunchy stuff. I hadn't solved that yet. Okay, so now we're up at 1600 or so. Are we? 550. How sensitive is this? Ooh, very sensitive. That's why you do it on this top end, I imagine. Okay, so if we want this to be a little higher, you're not seeing much of anything here, are you? So we're up around 580. Let's try it there. Now, is there any boost I can get on the antenna? Yes. Yes. Now it wants to go wide open. So we've gone from one side to the other. So I'm going to set this in the middle. And we're going to adjust the local oscillator. Tune a bit. Don't know, what am I doing? I don't really know. $15.80 at the top. Really should be just past 16. Think we can pick anything up with this radio yet? Let's give that a try. Take away this. Stand up the antenna here. And I'll take this off. No, don't take that off. Leave that on for now. That's the volume jack. Oh, the crackly stuff. We gotta deal with the crackly. A little hard to tune stuff in when it's crackling like that. What is doing that? Okay, I'm going to remove the just anything obvious at all about this. That's where it starts. Okay, right in the sensitive spot. Can't get down. It's gone away. Oops, I retuned it. Didn't mean to do that. I'm trying to discern the difference between the short that's happening, I think it's happening in here, and just the loss of signal from tuning. Get right in a... I've been fooled before into thinking there's a problem with the capacitor when there really isn't. That really sounds bad. Let's take a close look at the plate arrangement here. See if we can see something. See, the outside plate is bent out a little wee bit. And you bend that plate out until the regular trimmer capacitor starts ranging properly. I wonder. So there's one plate in there that's a little close. Capacitor is open and it doesn't make the problem appear when it's in this setting. These look really good. Okay, let's just tune and see if we can spot the moment. I'm wrong, these plates are completely closed, so the problem is there. Doesn't seem to be anything happening here. Where'd the problem go? I think it's just that really terrible gear there. Look at that thing. It's a very special gear. That gear there, I'll explain that in a moment. First plate on the left there is very, very close, but so it could be touching up in the back where I can't really get at it or see it. Looks really close there, doesn't it? So I'm going to bend that outside. Maybe not. Strange sound. What is all that? Can it be that? Definitely something wrong. Getting worse. I've had radios where just tuning them rapidly makes those kinds of sounds. And there's really nothing going on. So I'm looking for a moment where the supposed short circuit just kills the radio dead. Never seems to happen. I think I'm being fooled. This blade here. Something. This brown is it could be the contact in here is just like a brush contact, and it's just going to be whenever you're moving it. But when you stop, it's okay. Interesting. Tune slowly and get a shock. You get a shock doing something like that. Cool. I changed it. Wear the string out doing this. I think I may have changed it. Let's see. Sounds pretty normal now. I think I just didn't get this clip cleaned up enough. This is probably the major grounding point for the rotor. They don't want to depend on the ball bearings, and they don't want to depend on that little bearing at that end. I think that got it. I think that got it. Okay, Mr. Radio, what can you pick up? What can you pick up? Now, unfortunately for me, my shop is one of the worst places to operate a radio. So if this thing picks up anything, that's a good start. Okay, I don't know about the antenna angles here. And I want to go down here. Well, I think the tuning is much better. Here's somebody talking there. I don't think so. Okay, so we're going to force this radio onto 590. Okay, we're going to do that by putting out a 590 signal here and then tuning it in. Okay, that's going to be it. This is our best chance at picking up a station. I hear it. I hear it in one ear. Yeah, my left ear is open. There it is. Can we possibly improve that? I highly doubt it. The thing about these directional antennas is they have a very deep null. So it's more, if you picture yourself swinging the null around and trying to null out interference, it's probably better than trying to aim it at the station. That's kind of what I'm doing here. Get it to the quiet spot and you can hear the station. So that would be 590. On the dial. Yeah, I'd be pointing. Yeah, good enough. Well, I think again, if I took this into a better location in my house, it would work much, much better. This is just about the worst place to run a radio. So, I've done all that. I did all that with only 100 volts on the radio. Duh! Let's give it a little more juice back. Not going to make much difference in the alignment or anything. Okay, it's back into the cabinet. I will take it on a remote test, and we'll take one last look at it when I get back. I think that's going to need to put a patch up in here. Get rid of that hole. Same thing here. Need to put a patch on it. There's holes here, everywhere. Everywhere. Yeah, can't just stick some. I'm using nail polish here. I hopes it would work, but it's not going to. You have to put some actual band-aids on there. Okay, speaker patched up. It's really in bad shape, this speaker. Much worse than I realized. This was tricky to get off. It's going to be tricky to get on. Flip these buttons here. Ew, this is really terrible. situation with this radio. Oh my God, that's just horrible. Bottom plate goes on after. Bottom plate. I had the bottom plate on while I was yeah. Bottom plate's got to go on. Oop, not that way. Like that. Okay. And we'll put this back together. Okay, I took that radio out into my garage and it's picking up 5 or 6 stations. It's working really well. It's so surprising how long it's taken me to realize that this is trying to run these radios in my shop is a bad idea. There we go. Let's run the radio in the shop here. Let me douse the lights a bit. You can see the very nice lighting on this. It's quite nice. I don't think we're going to pick up too many stations here. I like this actually. Really nice glow to it. So it's on a station right now. Station there. These ones it was picking up quite clearly. Another one there. The French station. I heard it. In any case, how well it plays in here doesn't really matter because it plays really well elsewhere. So there we go. Another project done. Great. Fantastic. Somebody's going to buy this radio from the store that currently owns it. He's going to take it home and they're going to deal with all these little knocks really easily and make it clean it up really nice. And beautiful. Okay, well thanks a lot for watching the series. And what's next? Gee, I don't know what's next in here.